Hey, guess what jersey I'm wearing today? I'm a huge fan of Lionel Messi. Hey guys, welcome back to my YouTube channel. So in this video, I'm be sharing with you my data analysis project that I worked on. This time I decided to do something related to Bayesian data analysis. So without further ado, let's get into it.
Alright guys, so here's my project that I worked on. The title of my project is Quantifying Future Success, Bayesian's Approach to Predicting Goal Scoring Rates for Lionel Messi and Cristiano Ronaldo. So here's Lionel Messi here, Argentina, and Cristiano Ronaldo. So I'm going to give you a little storytelling. In the world of football, few debates ignite as much passion as the comparison between Lionel Messi and Cristiano Ronaldo. Both players have dazzled fans with their remarkable skills and extraordinary goal-scoring abilities. But what if I could use advanced statistical techniques to gain deeper insights into their performance? This project aimed to do just that, employing a blend of Bayesian statistics and nonlinear modeling to unravel the mysteries behind their goal-scoring rates. So here's where I got the data set. I got it from Data World, or it's basically a sport analytics, and it basically has a whole bunch of data sets related to sports, not just sports, but also different Excel spreadsheets you can find them at. But here you are. This is the whole data set that I downloaded. It's a small data set, but you can see there's seasons, players, Liga goals, meaning the number of goals scored by the players in the domestic leagues or the La Liga, and also the Liga assets, which is the number of assets made by the player in the domestic league. And we also have Liga apps, which is the number of appearances by the player in the domestic leagues during that season, and also the minutes, the goals, the assistants, and also there's a whole bunch more right here. And I also use Excel, R, SAS, and Python to incorporate with this my project. So the purpose of my analysis is to examine the trends in performance metrics of Messi and Ronaldo across multiple seasons and competitions. And by exploring these patterns, I aim to identify seasons where Messi or Ronaldo show exceptional performance in league of goal scoring and assist contributing capabilities, and to compare the performances between league matches and champion leagues matches to assess their adaptability and performance under different competitive pressures. Also to investigate any changes or trends in the performance metrics over the years, potentially revealing periods of peak performance or adaptation to different player conditions. And also to provide insights into the consistency of their performance across seasons and competitions, which shed light on their sustained excellence in their professional soccer. And I thought Bayesian statistics is an incredibly useful method in soccer and other sports. And it's a way for me, the reason why is because of incorporation of prior knowledge. Bayesian methods allows analysis to incorporate prior knowledge or expert opinions into the model, which can be particularly useful when dealing with players' performances, data that may have historical content or trends. Another is a probabilistic interpretation, meaning that Bayesian's inferences provides me a probabilistic approach, offering a more intuitive understanding of uncertainty and variability in players' performance metrics, which is essential for making informed decisions. And there's another one that I wanted, why I used it was because it's a way for me to update beliefs with new data. So as new match data becomes available, and Bayesian statistics provides a framework to update our beliefs to players' performances, and this continuation learning process helps in maintain up-to-date and relevant thoughts and insights. And basically, this analysis will contribute to a deeper understanding of how Messi and Ronaldo have performed over their careers, highlighting their strengths in different contents and providing valuable insights for soccer analysis and enthusiasts. And here's a question, is about how does the relationship between goals scored and minutes played differ between Messi and Ronaldo across different seasons? And can we model this relationship using linear and nonlinear regression techniques? And the purpose is to analyze how Messi and Ronaldo's goal scoring performances vary with minutes played using both linear and nonlinear regression models to capture potential nonlinearity and assess differences between the players over time. So here's a linear and nonlinear model using R that I provided with you. And on the right side, you can see the graph. You see the number of minutes played on the X, and the Y, the number of goal scores, and the player red as Messi and blue being Ronaldo. And you can see that the plot shows the raw data, and it's all pretty much scattered, so that they're all correlate out. So here's a linear model giving a summary. We could see that the linear relationship between goals and minutes for Messi is weak, as indicated by the low R squared. And you can see that the intercept is negative 11.9, which is not statistically significant, and the p-value is 0.66. And also the slope is 0.0168, and the p-value is 0.102, and the R squared is 0.3351, and the adjusted R squared is 0.2402. And we can see that the linear relationship between goals and minutes for Messi is weak, as indicated by the low R squared. But we can also see Ronaldo's, which shows a stronger and statistically significant linear relationship between goals and minutes. And the R squared value indicates a better fit of the model to the data compared to Messi. And here's a nonlinear model using a quadratic model. And the quadratic model does not fit the data well for Messi, since the parameters for the quadratic terms are not statistically significant, suggesting that a quadratic model may not be appropriate for Messi's data. And we can see that the linear term is 0.00814. That's in terms, but it's not statistically significant, or since the p-value is 0.384. And also for Ronaldo's, we can see that the quadratic model does not show also a significant parameters, and the quadratic terms do not significantly improve the fit of the model for Ronaldo's data. And here's a linear and nonlinear model using R, and you can see that the linear regression lines red for Messi and blue for Ronaldo shows a positive relationship between minutes played and goals scored. And the fit suggests that as minutes played increase, goals scored tend to increase linearly for both players. And you could see that the linear fit is reasonable, with the regressions capturing the general trends of the data points. And you can see that both players show a positive linear relationship between minutes played and goals scored. And the linear regression model seems to capture the trend reasonably well, with the goal scores increasing as player time increases. And here's a nonlinear and linear model using R, and the scatter plot here remains the same as the top, indicating that there are no visible quadratic relationships based on this plot, and the lack of visible quadratic curves suggests that the quadratic term may not significantly improve the fit over the linear model. And this is evident from the scatter plot and the lack of visible quadratic curves in the nonlinear regression plot. And since the linear regression model captures the trend well and the quadratic does not significantly improve the fit, it's reasonable to use the linear model for prediction and analysis. So here's some further investigation that I wanted to use. By conducting these additional analyses, I can gain a more comprehensive understanding of the relationship between minutes played and goals scored for Messi and Ronaldo, potentially uncovering insights that were not apparent from the initial scatter plots and linear regression models. But I decided to conduct a correlation analysis, a outlier detections using boxplot, and a visualizations with smoothing techniques, or called LOESS. So here's a correlation analysis. Basically, the correlation analysis helps me to understand the strength and directions of the relationship between minutes played and goals scored. So we see that the correlation coefficient for Messi indicates a moderate positive linear relationship between players played and goals scored, since it's 0.5789075. And for the correlation for Ronaldo, it's 0.8662526, which indicates a strong positive linear relationship between minutes played and goals scored. And we could also see that the strength of the relationship is much higher than for Messi's, indicating that Ronaldo's goal scoring is more consistently related to his playing time. And Ronaldo shows a stronger correlation between minutes and played, and this implies that Ronaldo's performance in terms of scoring goals is more predictable based on his playing time. While for Messi, there is not a positive relationship. There is a positive relationship, but it's not as strong, suggesting that his other variables might be influencing his goal scored ability. So here's a box plot detection, and a box plot is definitely useful for detecting outliers and understanding the distribution of data. So we see that the median number of goals scored by Messi is around 35, and the interquartile range, or IQR, is between approximately 30 and 45 goals, but there are no significant outliers in Messi's goal data, as all the values lie within the whiskers. And same with Ronaldo's box plot. We see that the median number of goals scored is around 35. The IQR is between roughly 30 and 45 goals. And there is no significant outlier similar to Messi's of the goal data. So we see that both Messi and Ronaldo's goal distributions are fairly consistent without extreme deviations, suggesting a stable performance range in terms of goals scored. And coaches in analysis can rely on these stable performance metrics to design training programs and strategies that optimize each player's strengths. And here's I want to show you another technique called loss or locally estimated scatter plot smoothing, which is basically a non-parametric technique that helps me to visualize trends in data by fitting multiple regressions in local neighborhoods. So we can see that for Messi's, the goals versus minutes played, the loss smoothing line for Messi shows a non-linear relationship between minutes played and scores scored. And there are definitely fluctuations you can see within the graph, with trends of both increase and decrease in scores as minutes played increase. And the confidence interval in the shaded area is wider in some regions, indicating that there is a higher variability in the relationship between minutes played and goals scored. And here's for Ronaldo, on the other hand. You can see that the smoothing line for Ronaldo also shows a non-linear relationship, but with a more consistent upward trend compared to Messi's. But you can see that the trend indicates that Ronaldo plays more minutes, and he tends to score more goals, although there are some fluctuations within the graph. And the confidence interval is relatively narrow, suggesting a more stable relationship between minutes played and goals scored. And the non-linear trends, especially for Messi, suggests that goals scoring is influenced by multiple factors beyond just playing time. And for Ronaldo, the more linear upward trend indicates that increasing player time consistently boosts his performance, while Messi's performance optimization may require a more tailored approach. And I'll use another technique called Bayes theorem. And using Bayes data analysis, how can we quantify the probability distribution of Messi's and Ronaldo's goal scoring rates in Liga matches based on their historical performance data? And the purpose is to apply Bayesian inference to estimate the distribution of goal scoring rates for Messi and Ronaldo in Liga matches, incorporating prior beliefs and updating them with observed data across multiple seasons. So here's the code that I wrote. And also I wanted to show you this. This is a prior distribution I put in my code. But the prior distribution in my beta analysis is defined using a gamma distribution. And I decided to use the gamma distribution with these parameters as a prior. And the reason is because the gamma distribution is a conjugate prior for the Poisson likelihood, which simplifies the posterior calculations. And I'll give you the formula. The probability density functions, or the PDF of the gamma distribution, is given by this formula, where alpha, or the shape, is A, and beta, the rate, is the inverse of the scale parameter, 1 over scale. So, for example, I used 2 as alpha and 1 as beta, since the scale equals 1. And so the prior distribution for the goal scoring rate lambda is given by this formula, for the likelihood. So we have gamma is equal to lambda times e to the negative lambda. And this suggests that I initially believed that the goal scoring rate is most likely to be close to 1, but allows me for some variability around this value. And the parameters a, when I chose 2 and a equal 2 and the scale equals 1, implies a moderate amount of prior knowledge, indicating that score goaling rates around 1 are somewhat expected, but allowing for variability. And the prior distribution I have defined for goal scoring rate lambda in my Bayesian analysis is a gamma distribution with a shape of parameter 2 and a scale parameter of 1. And this prior reflects a belief that the goal scoring rate is likely to be around 1, but can vary. And the likelihood function in my code represents the probability of observing the data given a specific value of the goal scoring rate lambda, and the likelihood is based on the Poisson distribution. So we can see that the Poisson's distribution probability mass function, or the PMF, for a given number of goals k and the rate mu is given by this formula, where mu is given by lambda times appearances, where lambda is the goal scoring rate per appearance, and the likelihood function calculates the product of these probabilities for all observed goals and appearances. And we see that the posterior distribution combines the prior distribution and the likelihood functions to update our beliefs about lambda after observing the data. In Bayesian inferences, the posterior distribution is proportional to the product of the prior and the likelihood. So we can see that the posterior distribution here, we can see that the mean goal scoring rates lambda for both Messi and Ronaldo is approximately 1.07, and this indicates that on average both players score about 1.07 goals per minute in Liga matches. And for the 95% confidence interval for Messi, the range suggests that there is a 95% probability that the Messi's true goal scoring rate lies within this interval, and the lower bound of 0.951 and the upper bound of 1.189 provide a range that reflects the uncertainty and estimate his goal scoring rate. And also for the 95% interval for Ronaldo, similarly, the interval indicates a 95% probability that Ronaldo's true goal scoring rate falls within this range, and the interval is slightly wider compared to Messi's. And we can see that they're suggesting a more uncertainty in Ronaldo's rate estimation. So we could see that the confidence interval for both players overlap considerably, indicating that while their averages rates are close, there is a degree of uncertainty in the exact values of their goal scoring rates. And the slightly wider CI confidence interval for Ronaldo suggests that there's a more variability in his scoring performance compared to Messi's. And then there is also some future performance I want to mention, is that the narrow confidence interval around the mean value suggests that the estimated goal scoring rates are relatively stable and consistent with historical data. However, the overlapping confidence interval means that the distinguishing between Messi's and Ronaldo's scoring rates based on the analysis alone is challenging, and the model indicates that both players have similarly high goal scoring rates with substantial overlap in their performance range. And here's an interpretation of the posterior distribution graph. We can see that the distribution for Messi, the posterior distribution of goal scoring rate for Messi's, is that the distribution appears to be centered around a mean value slightly above 1.0, indicating that on average Messi scores slightly more than 1 goal per match. And the distribution is also, we can see that it's slightly skewed, and suggesting that while most of the probability mass is around the mean, there is a small probability of higher goal scoring rates. And we can also see that the distribution is relatively symmetric, while with suggesting that there is most of the probability mass is around the mean, but there is a small probability of higher goal scoring rates. And the mean confidence interval of the mean of Messi's posterior distribution can be interpreted as the expected goal rate. And the interval gives us a range within which we can expect Messi's true goal scoring rate to fall 95% of the time, providing a measure of uncertainty. And also for Ronaldo's distribution, we can see goal scoring rate for lambda. The posterior distribution for Ronaldo's goal scoring rate is shown, and the distribution is also centered around a mean value close to 1.0, indicating on average Ronaldo scores about 1 goal per match, And the distribution for Ronaldo seems to be slightly wider compared to Messi's, suggesting a bit more uncertainty or variability in Ronaldo's goal scoring rate. And the mean of Ronaldo's posterior distribution can be interpreted as the expected goal scoring rate, and this confidence interval, 95% confidence interval, can give us a range within which he expect Ronaldo's true goal scoring rate to fall 95% of the time. So basically, we can both see that Messi and Ronaldo have a goal scoring rate centered around similar values, indicating that they are both highly prolific scorers in Liga matches. And the slight differences in the width and shape of their distributions, you can see both of them, can provide insights into their consistency and variability. Like, for example, if Ronaldo's distribution is wider, it may suggest that he has more matches with either very incredibly high or low goal counts, while Messi's might be more consistent. And some predictive insights I wanted to give on these posterior distributions is that these can be used to make further predictions about their performances. For instance, the distributions can inform us the expected number of goals in upcoming matches or seasons. And the Bayesian framework allows us to update these distributions as new data become available, continuing to refine our estimates. And here's one. How does incorporating prior knowledge about Messi's, Ronaldo's goal scoring rates in Liga matches affect our posterior distribution estimates based on their historical performance data? And the purpose is to analyze the impact of prior beliefs, prior distributions on our estimations of goal scoring rates used for Messi and Ronaldo using Bayesian's inference techniques. So I used SAS to use this. And you can see here's the output for Messi and Ronaldo's goal scoring rates. You can see that the posterior mean of lambda, Messi scores approximately 1.745 goals per match in the Liga matches. And we can see that this indicates that the variability around the mean score rates for Messi is relatively small, suggesting a consistent performance. And for the 95% HPD interval for lambda, this interval means that we are 95% confident that Messi's true goal scoring rate lies between 0.9485 and 1.2071 goals per match. And for Ronaldo's, we can see that this indicates on average scores approximately 1.039 goals per match in the Liga matches, and this suggests that the variability around Ronaldo's mean goal scoring is similar to Messi's, indicating a consistent performance. And the 95% HPD interval for lambda is that this interval means that we are 95% confident that Ronaldo's true goal rates lie between 0.9235 and 1.723 goals per match. And we can see that both players have similar goal scoring rates, with Messi having a higher mean rate compared to Ronaldo. However, the overlap in their 95% HPD intervals suggests that the difference is not statistically significant. And the impact of priors is that the analysis used in an uninformative prior, allowing the data to predominantly drive the inferences, meaning that the posterior distributions are reflective of the observed data without heavy influences from prior assumptions. And given the 95% HPD intervals and well-converged MCMC diagnostic, the goal scoring rates for both players can be used to make reliable future predictions about their performances in Liga matches. So here's a posterior distribution, same as the graph using Python, but I used SAS. Looks similar. So to wrap this up, by using the choice of models and the nonlinear Poisson model for goal scoring rates, I effectively addressed the nature of count data, and this choice provided me a more accurate and meaningful estimates than a non-linear model, which have given the discrete nature of the goals scored in soccer matches. And also with Bayes' theorem, I was able to use and update my beliefs about Messi and Ronaldo's goal scoring rates, and this method allows me to combine prior knowledge or prior distribution with observed data to obtain the prior posterior distributions. In other words, this allows me to seamlessly integrate prior knowledge with observed data, creating a posterior distribution that reflects updated beliefs about Messi and Ronaldo's goal scoring abilities, and this approach ensures that my estimates were grounded in both historical performances and recent data. And you can see that the analysis showed that the posterior distribution for both Messi and Ronaldo were centered around similar means values indicating comparable goal scoring rates. And this one to bring up is that the comparison of players of the analysis reveals that the posterior distribution shows that these findings suggest that their goal scoring rates in Liga matches are comparable and reinforcing their reputation, as you can see that they are top performers, and that's why they're known to be the best. And from further conclusions I wanted to mention and to point out is that there are uses of Bayesian inferences which incorporate prior beliefs and observed data, which proves effective in estimating the goal scoring rate of Messi and Ronaldo. And this method can be applied to other players or sports to obtain reliable performance metrics. And I thought this was useful because this methodology, which combines prior information and observed data, offers a robust framework for evaluating players' performances and can be extended to other players or sports for reliable performance metrics. And also for future models could also include additional predictions or predictors, match conditions, opposite trains, or home versus away games to improve the accuracy and robustness of the goal scoring rate estimates. And to improve these, I think these are definitely beneficial, and these can significantly influence goal scoring rates and provide deeper insight into player performances under varying circumstances. So thanks for watching my project related to Bayesian data analysis. This was a fun project I wanted to share with you since I've been a huge fan of soccer, and definitely you should play on. And here's my YouTube channel. Here's my other YouTube channels you can also subscribe to. So hope you enjoy this video. Please subscribe, and I'll see you in the next video.